welcome to another one of our pipeline safety videos, produced by Spiecapag, but freely available to all in the industry to help communicate worksite risks through practical demonstrations. We'll shortly be joined by guest presenter Tatum Ferrant to elaborate on today's topic, which includes working around pressurized hoses and fittings. Working around pressurized fittings and hoses can be dangerous, and there's a real risk of personal injury from a hose or fitting dissipating its energy in an uncontrolled manner. Typically, in the pipeline industry, personnel are exposed to this type of risk when working around pumps and compressors. When a hose or fitting fails under pressure, there's a risk of being struck by the hose, the coupling, being sprayed with the hose contents, and damaging your hearing from the sudden release of noise. There are several factors that can cause failure to occur. This could be incorrect design, selection, installation, inappropriate use, or physical damage including wear and corrosion to the hose and fittings itself. Most hose failures occur on the hose itself, not on the coupling. So you want to ensure a device like a whip check or whip sock is correctly fitted on the hose, not the crimped fitting. Simple measures must be adopted to prevent this risk from eventuating. Now, this could include visually inspecting the components, the installation of permanent brackets or anchoring the hoses to a solid structure, ensuring whip checks are installed on flexible hoses, or where possible fit shut-off valves and isolation valves, and simply prevent or restrict access to and around the pressurized hoses. To illustrate the dangers of pressure hoses failing, we've set up a demonstration which is behind me. Now, this is a controlled environment with a risk assessment and controls in place. Our first example demonstrates how a hose behaves when open-ended and unrestrained. Notice the erratic movement and uncontrolled nature of the hose. Our second example is a coupling failure with a poorly fitted whip check. Again, notice the amount of movement from the center point. Also notice how much movement there is as it is using all available slack in the hose. Even though a whip check is installed, it's still dangerous. Our final example is with a restrained hose with a taut whip check fitted. Notice the minimal movement and hose separation. These examples demonstrate the importance of correctly fitted whip checks, properly inspecting the hoses and fittings for wear and damage, and respecting exclusion zones. So now we've seen what happens when a hose fails, let's have a look at some simple controls that we can apply to our worksite. I'm here at PipeTech's facility and joined with Young Pipeliner of the Year 2021, Tatum Ferrant. Now, you know pressure, so I thought what better person to come and talk to about understanding how to control pressure and use it in a safe manner. When we're looking at our hoses in particular, what are some things that might jump out to us as not being suitable for the job?
So fit for service is really important. Before any test and before you use any hose, whether it's for high pressure or low pressure, you should always check to make sure that they are in good order. So some of the checks we do on a regular and on a daily when we are testing is we always check all our ends. Make sure we've got no cracks. Make sure the outer coating is on, like you can see on this one that's coming off.
Yeah, so the steel is starting to wear through. Yeah, exactly.
So this hose here, ourselves, we wouldn't use this. We'd tag that out. We'd get the ends cut off, we'd get them rechecked, and we'd put a new end on and make sure that they were fit for service. What you want to be looking for with your hoses is good, clean hoses. Make sure that the hose is in good working order, the outside case is well. At the end, there's no cracks or wear points around here. This is your highest wear area from when you're putting on and taking off on small hoses and also on large hoses. When you are fitting these to your fittings, make sure your swivel ends are moving correctly and your inside threads have got no burrs in them.
Nice. Okay, so that's the hoses. So when we're rigging our hoses up to a fitting or connecting a hose to another hose, we've got two options to make sure that if they do fail, they're not going to go flailing around. So the first one is a whip check. So that's what we've got here. So what does a bad whip check look like? What should we be looking for before we throw something out?
A bad whip check is something like this. On one end, we have our crimp. On the other hand, we have no crimp. So therefore, it's not going to be able to hold onto that hose correctly if it lets go. Also, if you follow down here, you're going to see some cracks and some wear marks where that steel's starting to let go.
Okay.
That's just from not being serviced properly, overused, not stored in the right conditions. So that one there, that would be tagged out or thrown in the bin and discarded.
Sure. So what does a good one look like then?
A good whip check is something like we have here, or something we have on our hoses at the top here.
Sure.
Both the crimps on both ends. We've got no wear marks, there's no rust.
Sure.
The crimp on the end moves freely and the spring moves freely as well. So when you put that in position on your hose, it's actually going to hold.
Sure. So we're looking for a good crimp on the end there with a washer supporting behind it, the spring in good serviceability and moving basically.
Correct.
Okay, so that's the whip checks, but what do they look like in practice? So we've got this rigged up here. On some sites I've seen previously, the whip check has been sort of coiled up in that fashion. That's not what we're looking for, is it?
No, what we want to do is have a good fixed anchor point at the top, and we want to have the whip check itself pulled all the way down.
Sure.
So if the hose does let go in any way from the fitting or letting go at the hose itself, it's going to have the least path to travel.
Sure.
We don't want it having it up the top where it can fly around.
Of course.
If it does let go and the whip check is doing its job, you want to isolate that hose out straight away, as long as it's safe.
Okay, so that's the whip checks. So now moving on to the whip socks, which is what we've got here. So what does a good whip sock look like? So
a good whip sock is something like this. They are both very similar, a whip check, a whip sock. They are both there to prevent anything happening in the case that something does let go. What you want to see when you install your whip socks on, this is on a 2-inch hose, whether it's on a small hose or a large hose. You want to make sure that it's not like this.
So no birds nesting.
No birds nesting. You want to have it pulled down and taut the whole way. So if it does let go, it's going to hold itself straight away and it's not going to fly around.
And so you're looking for some consistency in these diamond patterns here. If it's out of shape, then it's probably not fully locked in.
Exactly right. And you want to make sure that they are nice and clean. Exactly like we checked the whip check before, where it had the burrs and it was starting to crack. Before you install those, you just want to go through and make sure that you've got no burrs, there is no wires on there that are cracked or broken. Make sure your loops on the end, the crimps are okay. And when you fasten these, make sure you use a rated shackle. Okay, something that's been stamped. We don't want to use anything that's not stamped because when it lets go, there will be pressure on it and load. We want to make sure that it does hold.
Okay, excellent. So now just to sort of draw this to a close, are there any sort of tips or tricks that guys can look for and girls when they're setting up for a hydro test?
Be diligent around the hoses and around the testing and around any pressure. And if you're in your crew, do it together.
Absolutely, And you know, as we've been talking about with some of these other videos, it's all around the exclusion zone. Only the people exclusively involved in this activity should actually be in this area. So always refer to your safe work method statements and your risk assessments for any activity. Adam, look, you certainly know pressure, so thank you very much for spending some time today with me to run through all these bits and pieces. It's been great. Thank you very much.
Thanks.